So thank you, ladies and gentlemen. We are going to start our webinar. This webinar has been organized in the framework of the Galactica project, and today we will have the opportunity to know about the aerospace technologies for the textile sector, and of course related with the field of our speaker, that is automation and digitalization. Okay. Some recommendations for starting this meeting. Please turn off your microphones, okay, for avoid interruptions. If you want to have better signal, you can also switch off your camera. And of course, feel free to send you all of the presentation that you need through the chat. We will have at the end of the presentation, when we have 10-15 minutes to answer all of them. We're not sure if we're going to send the survey. If you receive it, please answer later. And of course, follow us at social network and feel free to share whatever you think, okay? First of all, I'm going to give you some snapshot about the project, okay? The Galactica project will try to generate new value chains in joining several sectors: textile, aerospace, and additive manufacturing. And we will have in this project the opportunity to be able to not only to receive important information and to know about the most important technologies developed in Europe, we will have also the opportunity to fund some initiative. If you go to the next slide, Eduardo, you can see that in our project we are developing, this is the overview of the project. We are working in some training sessions, webinars, and we are going to work in cross-sectional fertilization and so on, and matchmaking. Last week we had the hackathon, where we have an interesting company from the space sector working with textiles that won the hackathon. And in this today we are in the part of the project that is related with the dissemination with webinars. But tomorrow we will have the presentation of the call for financing project that opened last week. We are going to finance two different kind of projects. We are going to finance pioneer assimilation projects that are focused on exploration, feasibility, and to reach the minimum viable product to develop something in the market. And the second part of the project could be the orbital ones that could be more functional. That would be this kind of project will finance funding functional prototypes and also some text to markets. Okay. The objective of the project will be to generate new value chains. You can see in the next slide more or less information. We have 3 million euros for direct funding to support and 1 million for activities like training and coaching and so on. So we will wait that most of you would be participating in the next step of the project and will be join us at the call. I have to remind you that tomorrow we will have this presentation, and we will have also the B2B meetings to look for companies to present this kind of initiatives. Go to the next one, Eduardo. Today we are going to have an important research in Europe, that is Eduardo Ferreira, that is the head of the Automation and Robotics Unit at the Advanced Center for Aerospace Technology, CATET, is located in Seville, Andalusia. And Eduardo, if you go to the next one, Eduardo is telecommunication engineer. He has been working in the group, robotics group in the University of Seville, and he was also part of the Network Embedded System group. And he has been working on different kind of technology, and he is co-author of 8 international peer review related to artificial intelligence, their learning. Of course, has been working with aerial and ground robots, autonomous car, and anthropomorphic manipulators. Currently, he has been developing solutions for many companies from his job in the Aerospace Technology Center. And today, we are really exciting, and we are waiting. What are you going to tell us? Eduardo, please.
Yeah, well, actually, before starting, there was something that was not in my CV. I'm also a hackathon lover, so I was pretty jealous of the hackathon that you, Sylvia, and the people of Galactica organized yesterday, because it's one of my passions. I did a lot of them, and I wanted to be in there, and it was not possible for me. So I hope that you had fun while doing that. So yeah, thank you for the introduction, Sylvia. Today, my goal was to speak from an aerospace perspective about the industry and the automatization, and something that happens on the aerospace industry that is completely related to what happens to any other industry, like for example, the textile industry. So let's go a little bit deeper. So whenever we move to, for example, automotive sector, everybody has in mind the supply chain of Henry Ford. Automobiles moving forward and a lot of robotic arms like the one on the corner left, just creating the product. And also in the health sector, on the latest month, we see how the vaccines are developed by machines, everything completely automated. In the electronic industry, when we think about the cell phones, everybody thinks about a chain of robots working and doing the products. For the food industry, it happens more or less the same. But once we move to the aerospace sector and to the textile sector, the question is, does the automation deserve the effort? Yeah, I know that is actually a strange question, but the goal of this speech is to try to answer this question. The idea is to define what's the matter. So it depends mainly on the numbers. So if you are going to create, for example, t-shirts for the whole Europe, of course you require to automate, to perform automation. And in the aerospace, it's exactly the same. Whenever you are planning to perform, to create thousands of millions of airplanes, you need to automate. But the problem on both areas is whenever the numbers goes down. So yeah, let's go back again to the idea of this Henry Ford chain, about all these robotic arms working together and so on. What you see there on the screen is one robotic cell that we have here at CATEC with 4 anthropomorphic robots, pretty big machines, pretty expensive machines, and pretty dangerous machines. Those machines have to work on a robotic cell, they have to defend humans from themselves, and of course, if you know how to use them, they are extremely powerful and extremely useful if the numbers are big enough. But what's the problem? That you have to think on those robots like if you have a normal human worker. If you have a human worker and this human worker is working only at 20% of its time, you are wasting your money. So for those robots, the things goes exactly the same. So originally, when we started to work, and we started to work for the aerospace industry 10 years ago, we tried to make those robots to work on the most common task on the aerospace technology. So first, we started performing drillings, then we made them paint like humans will paint, but at some point we realized that the robot still has some times where it's doing nothing. It's actually a problem, so our goal was to try to not waste the time of those robots. And how did we do it? Here at CATEC we have a pretty important quality unit. So it's a unit that it's focused on trying to make all the pieces that belongs to the aerospace sector with the quality that the aerospace sector requires. So what we did was to start discussing with them and start to create tools specifically for those robots to try to increase the quality of the product. And at some point, it's just a matter of imagination. So you have from the one side, people that are expert in infrared thermography, in inspection, in ultrasonic inspection, in dimensional inspection. And then you have some other people that knows about artificial intelligence and machine learning. So if you mix everything together, you are capable of doing pretty amazing things. You are capable of doing, like, for example, end effectors like the one that you see on the screen. But then you come to me and you say, hey, just stop, because we are not a big company. We don't have such a big robot. We don't have such a big budget. This is way too much for us. Well, it's something that it's understandable. So not everybody can start with the budget of a really big company. So what the people nowadays is doing is to move to a new kind of robot that is called cobot. That is a robot that it's much smaller. Generally, the one on the left can go for 1.5 meter of reach, while the other one goes for, in general, just half of a meter. But the thing is that it's much smaller, it's much cheaper, and the most important thing, it cannot endanger humans. So those robots are the ones that on the latest years are the most preferred on the aerospace industry, just not only because they are cheaper, but also because they can work with the people around. So at the beginning, we developed an end effector that was, for example, capable of identifying the mistakes on the painting, like, for example, the system that you see on the screen. And then at some point, somebody in the aerospace industry told us, yes, this is really good, but we do not want to use such an expensive robot. We want to use a cheap robot, a robot that can work around the humans. So yeah, this is what we did. Just focus on having a little bit of imagination and prepare everything for the industry that you are targeting. But then you still speak to me and say, yeah, the robots, the automation, this is great, but we have a pretty big problem that, for example, for Galactica, we have only 100K. If we buy one of those robots that is 35K, we only live with 65K for making our development. Well, still, the problem is how large is your SME? How much pieces do you want to create? But actually, this is something that happens also in the aerospace sector. So the aerospace is also a sector that does not want to invest a lot on robots, does not want to invest a lot on automation, because you have to find out the trade-off between finding humans and doing the humans some works and finding the robots and doing with the robots some works. So here you have some other examples of what we do with the aerospace industry that I think are pretty much related about the things that on the textile sector we can do. So, for example, in the middle, you can see a system that it's using augmented reality. This system is helping the user while positioning several pieces in an assembly. And it's something that, surprisingly, it only costs 500 euros, but for that budget, the thing that you can get, it's amazing. So the user stops having problems while creating things. The user is guided while doing things. If you have to cut patterns, you can do it with that, and you do it faster. With a bit of imagination, you can even make it interactive. If you see on the center, on the top, you can see the user with some special gloves, just communicating with the system and telling to the system what does it want to perform. So again, the limit is the imagination or for example, on the left side of the screen, you see something related about the smart logistics. So you can create just a simple car, and prepare the system to detect what pieces are inside and which pieces are you moving from one side of the of your SME to another side. And this, that at the beginning seems to be pretty obvious, whenever you are growing bigger and bigger, it's really important for you, because then you don't lose your pieces, you don't lose the parts that you're moving, you start performing track of everything that you're doing and so on. And for example, speaking of that, the part of the right, it's a smart workbench. It's a bench that has some artificial intelligence. So I guess that you already heard about the deep learning. So this thing that seems to be dark magic, that it's capable of identifying persons and so on. So with just a little bit of imagination, you can also apply it on your supply chain. So here, what we did was just to adapt the things that are already on the market, the things that are already in internet, and I think that the video is not working well. Anyhow, adapt the system just to identify some pieces that goes around the workbench. This is something that we applied over Aerotechnic that has a tiny problem on their storage. That is that they have a data set of, well, they have 30,000 different pieces on their storage unit. So when the user is at this workbench, it has an order and it does not have an idea about which kind of piece is the one that he has to work with. So it's the workbench, the one that helps the user while doing that. And of course, you can use the most traditional ways of moving things, like for example with RFID and using also the QR bars, just to make your system more stable, more robust, and just to make it work better. In general, what happened with us. So we are a research center in South Spain that was created at the beginning just to work for the aerospace industry. At the beginning, we worked with Airbus, we worked with Arnova, we worked with Alfituri, with everyone. But then at some point, other people started to realize that everything that applies to the aerospace industry, it can apply to any other areas. So, for example, Securitas Direct, we have worked with them just to check if some clocks that they have to check if the users are failing down, or with Vodafone working with 5G, or with EMASESA, or even with the Hospital Universitario Virgen Macarena. So everyone came to us, and everyone came just with a problem, and we gave a solution. So what I want to say with this presentation is that at some point, what you can present to Galactica, it's only a matter of imagination. So if you have a budget, and this is what Galactica is giving you, the possibility of having this budget, then you can imagine whatever you want and just combine it with robots, with cobots, or just with deep learning to get whatever you want. And at the end, the results in general for those cascade fundings are pretty amazing. So, Silvia?
Hear me?
Yes.
Okay, Eduardo, thank you so much. It has been quite quickly in your presentation. Thank you so much. And now it's time to open questions for the assistant. I don't know if most of them has any questions. Please feel free to ask. Eduardo, it has been a very nice presentation. I would like to know if you have been working directly with any company, for example, related with aerospace, with the space specifically. Can you tell us something about this kind of activities?
Yeah. So for aerospace, we work with any kind of aerospace companies, like, as I said, Airbus, Ituri, Alestis, and so on. But also, we work with the textile manufacturing. In the last couple of months, the people of Ituri came to visit us because they had a problem about creating those gloves that you have to wear whenever you have COVID around, and they wanted just to automate this thing. Years ago, only 1 year ago, this is something that you just subcontract to India, you just subcontract to China, and then it costs what? Just €1 each glove. But then it comes the pandemic, and then they realize that they have a pretty big problem. They cannot do that at home. They cannot do that at Europe. And at some point, something that was only €1 per item, it requires an airplane, an urgent delivery, and it costs €12 per item. So what I want to say to tell with that history is that sometimes we just focus about, yes, maybe I could perform some automation here, or maybe I can just subcontract to India. But once you perform the automation, you are getting this work done here at home, here at Europe, and you are the one that you control the source, and you are the one that you control whatever you do. And I guess that this is one of the goals of the Galactica project, to be capable of bringing this power again to Europe, right?
Yes, of course. And we have received one presentation from Claudio Boto of the Enterprise Duct, and he asked, could you explain enhancement obtaining by use RFID instead of barcode?
If I can...
Could you explain enhancement obtained by using
RFID, yes.
Yes, instead of barcode?
Yeah. So the thing is the following. The barcodes are becoming in generally dirty. So if I go for the aerospace manufacturer, if I go to any kind of manufacturer, in general, there are some clean rooms and there are some extremely dirty rooms. Imagine that you have to paint something. If you have to paint something, the dirt can go to the QR code and you cannot see anything, and everything starts to fail. And this is why you have to sometimes move to the RFID codes, but then you have other problems that are, for example, whenever you are working with some metals and so on. So at some point you have to try to balance and to see which one is the one that deserves most for your application.
Mm-hmm. I don't know if there is any other question from the participants. Maybe meanwhile we are waiting for another questions, I would like to ask you one thing. For me, one of the most important opportunities that we have in this Galactica project is to join composites that are textile and other aerospace technology, and also, for example, automation of many things. Do you think that there is a good opportunity to join both technology in any challenges initiative?
Definitely. So the thing about the advanced manufacturing, the thing about being capable of creating whatever piece just on a fly, it's that you can just define your process, define your project on another way around. Instead of saying, hey, this is my goal and this is what I'm going to achieve, you can actually take a more research perspective and say, I'm going to achieve that, but I'm going to try it on that direction, on that direction, and that direction. And you can perform, and you can prepare some specific things, prepare for exactly what you want to do. Just print it and have it here in a couple of hours.
Okay, we have received another question from Claudio Boto and said, what's the correlation between artificial intelligence and deep learning?
Between artificial intelligence and deep learning. Okay, so artificial intelligence is whenever you make your automated system think or behave as a human. So things or behave as a human is like, for example, if you have a door in front of you, you discover that this is a door, and you know that this is something that you can open doing from something like that. So this is artificial intelligence. And inside of artificial intelligence, there is a whole area that is the neural networks. And inside of those neural networks is this area that are called the deep learning. That is the most novel way of using neural networks. The neural networks, it's again the same thing. You are imitating whatever the human does, but in this time you are imitating what the brain does to identify something or to do something. And the deep learning, what does is, instead of using a really tiny part of the brain, that was what we were capable of 20 or 30 years ago, now with the novel computational things and so on, you can have almost a whole brain. But of course, the problem is that we are not as good on the technology nowadays to really replicate the brain. But it's good enough to detect if, for example, what you have in front of you, it's a door.
Okay, and we have another question saying, what tool have you used in the deep learning application? Image recognitions?
In general, we use image recognitions. We use a lot of something that is called the CNN. It's the convolutional neural networks. They are not the only ones that we use, but are the ones that we use the most. And the things that I recommend the most about the convolutional neural networks is that you go for something that it's called the transference learning. You go to internet, you take something that it's already working, something that is already trained, and you prepare it to work for your specific purpose. So it's like, hey, I have the brain, but I do not have just the brain. I have the brain trained to identify chairs, to identify, for example, t-shirts and so on. And now you train it to do it something else. This is what it's called transference learning, and this is the most amazing thing that you can do with artificial intelligence. Mm-hmm. However, we also work a little bit with reinforcement learning and something that is called the co-learning, that is combining the reinforcement learning with the deep learning, and then everything starts to be extremely big and hard to handle.
Okay, I don't know if there is any other question from the panelists. I think, Eduardo, maybe you can explain a little. How do you try? No, we have received another question. Okay, correlation between imaging analysis and defectology can be made completely automated, or is there in the need of extra human judgment?
So yeah, a pretty good question. Okay, so I already told you about the idea of you have this little brain and you make it do something else. The goal, or what we do, is not just to have this brain, but to train it to do things. And when we train it, in general, are humans that were the ones that train it. So for example, for painting, what I do is I have a human that detects those mistakes. And then I have this little brain that tries to replicate what the human says. And at some point, this little brain becomes as intelligent as the human. And then you say, yeah, you are replacing the human on that. Yeah, but the problem is that the poor human, whenever has to review a piece that it's like 20 meters big and it has mistakes like from that size, believe me, the poor guy really hates you whenever he has to work on that task 8 hours a day, 5 days a week during his whole life. I don't know if this answers the question.
I hope so. If not, of course, you can open your microphone and ask. We have received one question from Giuseppe Luis Pascual. He writes, we are checking fabrics that that have been additive manufacturing with silver and copper irons. We want to certify their antiviral properties. Until now, we have done it to make the fabric anti-static. I don't know if you could even work with a possibility of harnessing this shade power as personal device charging power. Wow.
Wow.
We can explore.
Well, actually, to be honest, this is one of those questions that I will really recommend to raise tomorrow on the B2B. And the meaning of why I'm suggesting this is because even if I'm the one that works with automation and robotics, I do believe that a couple of days ago, another person did also a specific webinar about additive manufacturing, and it's going to be tomorrow there. And I'm pretty sure that he will be much better than me answering this question. Is that right, Silvia, right? So tomorrow is Lasagne going to be there, right?
Yes, I hope so. I think that he has joined the platform for the B2B meetings for tomorrow, and you can, of course, request B2B meetings with him and with you, I think so. I'm not sure if Fernando has joined, but if not, we will tell him to join.
Okay. I'm sorry for not being able to answer such a question.
But Eduardo, don't worry, because if someone tomorrow asks you to have this discussion, they can request the meetings to you, and you can add Fernando at that moment if it needed. The tool allows you to join a specialist in any case. Okay.
Really nice.
Okay. So I don't know if there are more questions. What is clear is that aerospace technology presents many opportunities to improve textile sector, and the other hand, and on the other way also, because many textile technology has become to the aerospace sector to be intrinsic part of our developments. And if there is no more question, I think that we can finalize. I don't know if anybody has another question. Last minutes for that. So I think that tomorrow we will have enough time to have many discussions in the B2B meetings. Of course, don't forget that we have in the morning at 10, if I remember well, we have the presentation of the call, and we will for all of you and all of your proposal, of course. Thank you so much, Eduardo, for your participation. It has been great. And
thank you very much for inviting me.
Okay, thank you so much. And I hope to see all of you pretty soon. Okay, thank you so much.
Thank you.
Bye.
Bye.